Okay, so the next board up for repairs is one that I just acquired. Got this on eBay, and it is considered the 7th coin-operated video game to be released ever. So it is a clone of Atari Pong called Rally. Okay. I don't remember the name of the company, but it's easy enough to look up if you're interested. But this should be a direct clone of Atari Pong, or at least very, very close. And so this is the 7th video game ever released, coin-operated video game ever released. Of course, Computer Space is number 1. I think Atari Pong is considered number 2. But yeah, number 7. So this might be interesting to some collectors. I don't know if it has any value. I don't know. I just thought it was really cool, so I bought it. And I think this is interesting. One of these chips is all gone. The only thing left is the lead frame. I think that's really interesting. So I've got to replace that, and then I need to. Well, actually, I'm going to clean it first. That's the first thing I'm going to do is clean it, get it all nice and shiny, all this dust off of it. Replace that. Build a connector. If it's a different pinout than Atari Pong, I may have an Atari Pong, but I don't think I do. I'll probably have to build a connector, test harness, I should say. And then it's off to the races. So that will be coming up. Okay, so I gave the board a quick clean, and it still looks dirty. I mean, that dirt must have been on there for years. And I scrub and scrub and it comes off, but it just doesn't look clean. It is clean. It was loose on there, and now it's just stubborn stuff that's on there. I went ahead and created a test harness for it, so that's done. Still need to install a chip where that broken chip was, so let me do that. Let me put a socket and install that missing chip, and then we will be ready to see if this board works or does anything. I'll be back. Okay, so I studied this board before I started building the connector, actually, and confirmed this is the exact same pinout and chip layout. The whole board is laid out the exact same as an Atari Pong. So from the Atari Pong documentation, they give you the board layout, and the chip that's missing is a 9316. So I put in a 9316 there, which is the same thing as a 161, but I am putting a 9316. And that's a 4-bit counter if anyone's interested. So the unknown here is I don't know where the sync signal is going to be. I think it comes from one of these resistors. So my sync wire has to be able to reach to it, and it does. So that's what I'm fixing to power this up for the first time. Yeah, let's do it now. All right. Voltage is going to be about 0.4 below that, so it should be right at 5 volts at the board. And oh, did I forget to plug something in? No, the screen is on. Connector's plugged in. Oh, something's getting hot. I gotta turn it off. Something's getting hot. Oh, I put that chip in backwards, so it's probably trash. Oops. All right, I'll be back. Okay, so I took this 9316 that I had put in here backwards and put it in right and checked it with the scope, and it is bad. I put a 74161, and the outputs look good on this one, so it should be good. But not getting a video. Still not getting a video. So I need to probe around and see if we even have a video signal at all. But we do have a clock signal on this. I'm not sure if that's the clock chain or what that is. Probably the clock chain. Let's see. That's going to be location B3. And the clock chain is going to be up here. No. It is not part of the clock chain. Where is B3? B3. 161s. Okay, B3 is right there. This is the ball vertical position counters, I believe. And the fact that we got action on them means there should be video more than likely. Let me probe around the video circuitry and see if there's a bad gate. Okay, so we're getting some to the screen. The problem was this connector here is sloppy on the board. This 22 pin fits sloppy. It can move quite a bit either direction, and it was all the way to one side, and it just wasn't making a connection for the video. So it looks like we're getting something now, but the screen's too bright. So let me try to turn down the brightness. Let's see, brightness. right, now, obviously not syncing, but I don't have the sync hooked up. So now I've got to figure out which one of these resistors. It's going to be one of these, I think. So let me see what this one does. I'll just let you watch the screen. That doesn't do anything. That does something. That doesn't do anything. That's not doing it. Well, I guess it's this one. I guess that's the sync signal. Little off center on a TV screen. These would normally be on a black and white TV, and that would be adjustable. But on this monitor, not much adjustment for the width. There is a horizontal width yoke and choke in there, but it's not going to be, I don't think it would adjust that much out. At any rate, looks like it's freaking working. Let me see if I can credit it. Oh, that doesn't look good. Okay. So it looks like the reset's not clearing the scores correctly, isn't it? Let me adjust that brightness down a little bit more so we can get a better picture. It's got retrace lines in it. Those lines going across, retrace lines. Why? I must not have the right signal for sync yet. All right, let me probe around, see if I can find a better one. Okay, so you can see I've got a better picture now. And this point here is still just is the only sync position, the only place I can grab the sync. So that is correct for that. The reason the picture was bad before is the design is slightly different for the Rally board compared to the Atari board. The Atari board has a 5 microfarad capacitor here, but this spot here is where the capacitor would go on this board, but they just bridged it. So they compensated for that capacitance in the TV. You know, a black and white TV back then had a lot of different ranges for bright and contrast and such. This monitor doesn't have that. So what I did was I added a 4.7 microfarad capacitor here to compensate for that missing capacitor that would normally be there on an Atari board, that is. This is not Atari, obviously. This is the Rally. This is actually 4Play is the name of the company, 4Play. So putting that capacitor in dramatically changed the brightness, the intensity level. So I had to turn down, or I'm sorry, I had to turn up the intensity to get a picture. Before it was really bright, if you remember, and I had to turn it way down. So that capacitor compensates for that. So yeah, now that we got the image done, I can coin it up, but the scores don't zero. So that's the problem that I got to fix. These need to be 0, 0 to start with, obviously. The controls, they work. I can move them, both of them. So reaching over here. So both of them are working, and both of them have full range, and they feel good, and they look correct. They're nice and linear. So the controls are good. But if you look at the schematic for Atari, if I can find it, give me 1 second. Okay, so the schematics for Atari don't have a serve button. So why isn't the ball being served? Well, it's either because there's a serve button on this board that I need to hook up, but it doesn't look like that's the case, or there is a circuit that automatically serves the ball as a countdown or something, and that's not working. So I need to study the schematic and compare it with the board I have. One thing I'm noticing about this stuff is I was probing around in the video, in particular this inverter here, and these, not that one, let's see, where is it? Anyway, so that inverter, crap, oh, okay, this stuff here. These chips are in the proper location. Sorry, these chips are in the proper location, but the pinouts aren't matching. So they put the same layout, but they redid the connections. So like this chip, I don't know which one it is, but it's not pins 10, 11, and 12. or 11, 12, and 13 actually. So the signals aren't matching what they should. And and this one here in particular, this inverter it is at E4, but it's not 12 and 13. And this this 4-input NOR gate, let me see. No, 4-input OR gate, that guy is not at 10, 9, 10, 12, 13, and 8. Okay, it's not there. They remapped it. So it's hard to track down stuff. I really need the actual schematic, but this problem here, I probably will figure this one out okay without having the exact schematic. So as long as the problems aren't too difficult, I should be able to figure it out. All right, so let me see if I can figure out why this reset's not working, and I'll be back. Okay, so studying the schematics. This is the Atari Pong schematics. This counter, this flip-flop, this counter, this flip-flop. These are the 4 chips that hold the scores between the 2 players. This is probably the left player, this is the right player, it doesn't really matter. When I hit the coin switch, everything resets, and these are supposed to be cleared, and they do. I've checked with the scope that these are all stored as zeros for the score. The display being wrong for the score, therefore, is some other problem, some logic problem. I haven't isolated that yet. I started focusing on the serve, ball serve, and that comes from this circuit here. This signal here needs to go low, but is not happening. There's a D flip-flop here and some logic, and here's where the timer comes in. There's a 555 timer. This is what's used to delay the serving of the ball. Well, this thing is never getting triggered. I checked this chip and no signal's getting there. I checked this chip, no signal's getting there. Let's see. At some point, the signal stops. I think it's here. I think this one is, I think this is going low, and this is staying high, and this is a NAND gate, so both of them are high, and this is showing up as a high, which is wrong. So I'm going to try to replace this chip to see if that doesn't fix the server problem. After I get the server, the ball serve stuff hammered out and working, then I'll focus on the score problem. But I'm going to try to replace this E6 chip and see how that goes. Okay, so I replaced that 7400 for a quad, I should say, a quad 2-input NAND gate. And it now serves the ball. The score being reset still doesn't work, and I don't have sound. But the auto serve is working. And the hit detection of the ball with the paddle seems to be working. Let's see if the ball speeds up. It should speed up and change direction eventually, I would think. Or not. So that may be a problem with that. Oh, there it goes. Okay, so it took quite a few hits, but I think that was probably correct. Notice that the score isn't doing anything. Oof. I can do it. The score did something. So there's no randomization of the serve. It just always goes the same place. Ooh. Okay. So I'm thinking that if the game ends ever and the score is wrong, then that means the 7448 may be the problem. Because that means all the other logic, the score keeping, the game over sensing, all that's going to be correct. So I don't hear sound, so that'll be the next thing I'll want to figure out. It's weird how both scores are affected. No sound. Whoa. I have no idea what the score is. Now, if it just keeps going indefinitely, then obviously there's more to it than just the numeric display chip, 7448. but the gameplay seems to be correct. Both paddles are registering. And if you hit off to the edge, whoops, sorry. If you hit off to the edge, then that's working. Okay, so game over. So the logic is correct. This was set to 11 points to win it. There's a dip switch for that right here. So it's set to 11. I believe the score was 11 to something, maybe 11 to 5. I'm not sure. But so that tells me it could be the 7448. That'll be something I investigate, but not tonight. It's getting late. So what I've got to do, I've got to fix the score display and I've got to fix the audio. And then after that, we'll reevaluate and see what other problems there are. Hey, thanks for watching, but that's it for this video.